Good afternoon. I'm Stewart. I'm a PhD student in the Geotechnics department at Imperial College London. I'm sponsored by Radioactive Waste Management Limited. I'm exploring how rural scatterers and vegetated areas can complicate the time series deformation measurements we derive from INSAR. A particular concern is that these rural areas are transient in terms of their scattering behaviour. Phase shifts due to changes in scattering can cause ambiguities and inaccuracies in deformation measurements. Such phase changes might be produced by changes in soil moisture, as authors such as Dzan have highlighted. Other authors, such as Zweiback, have shown that similar effects can be caused by changes in vegetation as well, with the structure, biomass and moisture content of the vegetation all playing a role in affecting the interferometric phase. We can investigate the magnitude and consistency of scattering phase shifts by using a priori maps of vegetation and soil type. Here, for example, we've used a priori maps of crop type to spatially separate a stack of time series INSAR data. After removing topographic phase using a high-resolution DEM, and then calibrating out the atmospheric phase screen using nearby persistent scatterers, we arrive at these seasonal patterns in phase behaviour, strongly correlated within the different types of crop. The relationship between this phase anomaly and other SAR measurements such as amplitude and coherence can then be mined from the data sets. We hence predict the interferometric phase based on the crop type and the non-phase SAR observables. In literature, measurements of amplitude and coherence are often used to classify land cover and track the time series properties of vegetation. Therefore, rather than rely on a priori maps of soil and crop type, which might be limited in terms of availability or temporal resolution, we can instead use the SAR data itself to distinguish scatterers with different transient behaviour. Here, we analyse the time series of amplitude and coherence, then feed this data into a k-means clustering approach. Here, we see cluster labels for an area of interest in South Wales, United Kingdom. The labels have been assigned based on the k-means clustering algorithm. These two blue labels correspond to peaty soils in the Brecon Beacons area. They're distinguished from grasslands on slopes and more freely draining soils in lower lying terrain. Forested areas appear in dark red at the centre of the image. In the fertile Vale of Glamorgan area, the labels have been automatically assigned to different crop types. Despite the fact that this South Wales area of interest is very well vegetated, we can still receive significant coverage and accuracy of deformation measurements when we calibrate for this transient scattering phase. Compensating for the phase anomalies allows us to observe a wider range of deformation phenomena than was otherwise possible, highlighting a range of movements relating to slope stability, historical mining, and the settlement behaviour of made ground. Transient behaviour in the scattering can cause complex behaviour in interferometric phase. In rural areas, these phase shifts might be produced by changes in soil moisture content, or changes in the moisture content, structure, and biomass of vegetation. By distinguishing scatterers with similar properties in time series, we can observe consistent anomalies in the mean phase we'd expect after accounting for APS and height errors. By using the k-means algorithm, we can cluster different scatterers based on their time series behaviour. We can isolate consistent patterns in phase which affect the coherence matrices. After correcting for this phase anomaly, we see an increase in the coherence of the phase time series, and correcting for this phase leads to more accurate and less ambiguous measurements of deformation behaviour. Thank you for watching this short presentation. Apologies I couldn't go into greater technical detail with the time available, but a paper containing much more comprehensive detail on the approach should be published soon. There's also some additional references in the abstract, but feel free to get in touch. Thank you very much.